This is a review for your quadratic equations test. So we're going to start off with simplifying the following. So you've got complex number plus a complex number. So here we're going to add our two real parts, 5 and 2. So 5 plus 2 is 7. And our two imaginary parts, positive 3i minus I, is going to give us a positive 2i. Our next two complex numbers are multiplied. So whenever they are multiplied is whenever you have to do double distribution. So 5 times 2 is 10. 5 times negative I is negative 5i. 3i times 2 is 6i. And 3i times negative I is negative 3i squared. Now I know that I squared is equal to negative 1. So negative 3i squared is the same as negative 3 times negative 1, which is a positive 3. So I'm going to replace that with a positive 3 right here. So 10 plus 3 is 13. Negative 5i plus 6i is a positive I. Number 2, evaluate these numbers. So the square root of negative 49, so it's a negative, so I know I'm going to have an I on there. The square root of 49 is 7, so that is 7i. Square root of negative 36 over 121, I know I can break this up into negative 36 over square root of 121. Square root of negative 36 is 6i. Square root of 121 is 11. Simplify the following as much as possible. So 40. So 40 can be written as 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So I have a set of 2. So this set, I can write this as the square root of 4 times the square root of 10. Or I can skip straight to 2 root 10. 48. That's 2 times 24. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. Here I have two sets of 2. Or I could write it as square root of 4 times the square root of 4 times the square root of 3. Square root of 4 is 2. Square root of 4 is 2. 2 times 2 is 4. Root 3. The equation 5x squared minus 3x plus 5 equals 0 has how many real roots? Okay, so I know that the real roots can be determined by the discriminant. The discriminant is the part of the quadratic formula that is underneath the square root symbol. So x is equal to opposite of b plus or minus the square root of b squared minus 4ac over 2a. That is our quadratic formula. Our discriminant is the part right underneath this. So this part right here is the discriminant. And that discriminant tells us how many real roots I have, because I'm taking the square root of it. So b squared minus 4ac. If I'm taking the square root of a positive number, that's one that's greater than 0, I know I'm going to have 2 real roots. If I'm taking the square root of 0, I know that I have 1 real root. And if I'm taking the square root of a number that is less than 0, then I'm going to have 2 complex roots, or imaginary roots. So, or no, I can also say that it's no real roots, because it won't actually touch or cross my x-axis. So here my a value is 5, my b value is negative 3, and my c value is 5. So when I plug this in, I'm going to have negative 3 squared minus 4 times a, which is 5, times c, which is 5. Negative 3 squared is 9, minus 5 times 5 is 25, times 4 is 100. Which is a negative 81. So that means that I'm going to have no real roots. So my discriminant's negative 81, and that lets me know that I'm going to have no real roots. The equation for 3x squared plus 18x plus k equals 0 has exactly one real root for x, and k is a constant. That means that it's just a number. It doesn't have a variable attached. Find the value of k. So that means that my discriminant, if it has one real root, my discriminant equals 0. So b squared minus 4ac has to equal 0. If I plug these numbers in, I know my a is 3, my b is 18, my c is k. So 18 squared minus 4 times 3 times k equals 0. 18 squared is 324. So 324 minus 4 times 3 is 12k equals 0. I'm going to add 12k to both sides and have 324 is equal to 12k. Then I'm going to divide this by 324 by 12. That gives me 27. So k is equal to 27. So when k is 27, it will have one real root. And that's because that's when my discriminant is equal to 0. Number 6, solve the following by completing the square. So completing my square, my first thing I need to do is move this 13 over. So I'm going to have x squared minus 8x is equal to negative 13. Half of negative 8 is negative 4. Negative 4 squared is 16. So I'm going to add 16 to both sides. Then I'm going to factor this side so that it will give me x. Half of negative 8 is negative 4. So x minus 4 squared is equal to 3. Take the square root of both sides. X minus 4 is equal to plus or minus the square root of 3. Add 4 to both sides. X is equal to 4 plus or minus root 3. On B, I want to go ahead and divide everything by 2 so that I don't have this 2 in front. So x squared minus 10x plus 5, 2 goes into 5 twice, 1 left over, 2 goes into 13, 6, 0.5 equals 0. Then I'm going to move this 26.5 to the other side. X squared minus 10x is equal to negative 26.5. Half of negative 10 is negative 5. Negative 5 squared is 25. So this will be x minus 5 squared is equal to negative 1.5 or negative 3 over 2. Take the square root of both sides, so I have x minus 5 is equal to plus or minus. Now this is a negative, so I need to put an I out front. Square root of 3 over 2. And I can't leave this over 2, so I'm going to multiply top and bottom by that denominator by 2. So I have x minus 5 is equal to plus or minus I root 6 divided by 2 times 2 is 4. The square root of 4 is 2. Add 5 to both sides. X is equal to 5 plus or minus I root 6 divided by 2. 7. Solve the following using quadratic formula. So quadratic formula again is x is equal to the opposite of b plus or minus b squared minus 4ac all over 2a. So on this first one, my a is 1, b is negative 5, and c is 7. Nice thing about quadratic formula is that it will always work. Sometimes it takes a little bit longer, but it will always work. So opposite of negative 5 is positive 5. Plus or minus negative 5 squared is 25. Minus 4 times a, which is 1, times c, which is 7. 4 times 1 is 4, times 7 is 28, over 2a. 2 times 1 is 2. X equals 5 plus or minus 25 minus 28 is a negative 3 over 2. X is equal to 5 plus or minus I root 3 over 2. Alright, on our next one, A is 1, B is 3, and C is negative 8. So x equals opposite of negative 3, which is negative 3, plus or minus the square root of 3 squared, so that's 9, minus 4 times 1 times negative 8. So that's going to be a negative 32, minus negative 32 would be plus 32, over 2 times a, 2 times 1 is 2. X is equal to negative 3 plus or minus root 41 over 2. Root 41 can't be simplified, so that is your answer. Solve by factoring. The numbers that multiply to give us negative 8 and add to give us negative 2 is a negative 4 and a positive 2. So that will give me my factors of x minus 4 and x plus 2 equals 0. So I can set my two factors equal to 0 and solve those. So x could be 4 or x could be negative 2. I'm going to add 4 to both sides, or sorry, I'm solving this. It says by factoring, but this would be simpler to solve using square root. So we're going to solve it square root. So 3x squared is equal to 8 plus 4, which is 12, divided by 3. X squared is equal to 4. Square root of both sides. X is equal to plus or minus 2. So it could be 2 or negative 2. Solve the system of nonlinear equations. Alright, so I know that these two are equal when they're I can set them equal because they're both solved for y using substitution. So 2x squared minus 2 equals negative 2x plus 2. I want to put everything on one side, so I'm going to have 2x squared plus 2x minus 4 equals 0. Now I'm going to divide everything by 2, so I get x squared plus x minus 2. Now my numbers that multiply to give me a negative 2 and add to give me a positive 1 are 2 and negative 1. So this will give me x plus 2 and x minus 1 equals 0. I can set both factors equal to 0, x plus 2 equals 0 and x minus 1 equals 0, and solve those. So x can equal negative 2 or x could equal positive 1. Those are my x values. Now this is a system, so these are going to intersect at actual points. So I also need to find the y values for those. I can plug these numbers into either equation. I will have two answers here. So negative 2 times, if I'm looking at negative 2 plus 2 equals, negative 2 times negative 2 is 4. 4 plus 2 is 6, so that is my first y value. So negative 2, 6 is one point where they will intersect. The other point, negative 2 times 1 plus 2. Negative 2 times 1 is negative 2, plus 2 is 0. So that will be that y value, so it'll intersect at 1, 0. So these two equations will intersect at the points negative 2, 6 and 1, 0. Solve the inequality. Negative x squared minus 10x is less than 21. Okay, you can solve this graphically in shade and be able to see that whole region, or what you can do is you can put everything on one side. So negative, I'm going to move everything to the right, so I get x squared plus 10x plus 21 is greater than, if I've moved everything away from there, I'm going to have a 0 on that side. Okay, so I added x squared, added 10x. And that is all greater than 0. So x, the numbers that multiply to give me 21 and add to give me 10 are 7 and 3. So x plus 7 and x plus 3 is greater than 0. So I know those are the only two places, or sorry, set my factors equal to 0 and solve. So x can be negative 7 and x can equal negative 3. So I know negative 7 and negative 3 are the only two places where my quadratic can cross the x-axis. So I know that it's either going to look something like this or it's going to look something like this. And I want to know where it is greater than 0. Okay, so I want to know where if it's outside or inside these 2 points. Alright, so the way I can do that is I can put in what we call test points. So I can put in a number that is less than -7 and see if it gives me out a negative or a positive. Okay, the easiest way to do that is into the factors themselves. So x plus 7 and x plus 3 has to give me a number greater than 0. So -8. -8 plus 7 would give me a negative. -8 plus 3 would give me a negative, and a negative times a negative is a positive, which is greater than 0. So that means I'm going to shade this right here. This is going to be an open circle because it's greater than 0, not a greater than or equal to. A number between -7 and -3. So I could choose -4. -4 plus 7 would be a positive number. -4 plus 3 would be a negative number. A positive times a negative is a negative, so this is not true, so I'm not going to shade this region. And then a number greater than -3, which easiest one would be 0. 0 plus 7 is positive. 0 plus 3 is positive. Positive times a positive is a positive, so I'm going to shade this region. So that means that my solution for this would be from -infinity to -7 and from -3 to infinity.